day or part 2 of day 1/day 2. Yesterday, or the video that you watched last night, we left off with identifying sequences. So this would have been an arithmetic sequence, this was a geometric sequence, and then you'd find the common ratio and common difference. Now, sequential notation, that's the notation we use for sequences. And sequential notation uses what's known as subscript notation. Okay, so make sure you guys get that down. Sequential notation uses what's known as subscript notation to identify each term in the sequence. Okay, I'm going to highlight this subscript notation, and that is right here. Okay, and it's very similar to function notation, which we should know how to read. How to say it? Function notation, if I see f with n here, recall that it's just saying f of n. Okay. So how to say it? You would say f of n. How to use function notation. This should be review. If I'm given f of n equals 2n plus 1, find f of 4. Well, I'm just replacing n with 4. So it's going to be 2 times 4 plus 1, and that comes out to 9. Right, this is function notation, evaluating functions. And how is it written as an ordered pair? Here it's saying n, comma, f of n. In other words, it's like saying x, comma, y. Okay, so that's function notation, nothing new. And now the new one is subscript notation. And again, this is what we always use when we are working with sequences. And the way I would read a sub n is exactly how I said it. A sub n. It's kind of like a subscript in typing in Microsoft Word or something. You have superscript and you have subscript. Well, when it's lower on the bottom right corner, that's what's known as subscript. So we read it as a sub n. And how to use it? It's actually the same exact way as evaluating functions. Wherever I see n, find a sub 4. This is saying to plug in 4 for n. 2 times 4 plus 1 is 9 as well. And a sub 4, this is really, if you want to put this down, this is the 4th term in the sequence. Nice little addition to know. A sub 4 means it's the 4th term in the sequence. And it also came out to 9. Okay, and let's just be extra here. How it's written as an ordered pair, n, comma, a sub n, just to make sure we understand. If I had a sub 1, that's like saying that's the first term in my sequence. If I had a sub 2, that's my second term. A sub 3, a sub 4, so on and so forth. Okay, so again, what we just did in blue, this is what we use for sequences, subscript notation. Let's go on to the back page. It's giving us some exercises. Given the following sequences, part A, identify the terms using subscript notation. Part B, state the next 3 terms in the sequence. Part C, describe the type of sequence, and then part D, state the type of function. So really all 4 of these go hand in hand with each other, maybe except for part A, but it still should be simple with the exercises that we've been doing in class with our notebook. So let's go ahead and solve these. So for number 1, identify the terms of the sequence using subscript notation. Okay, well, let me put A right here. What I always like to do, I look at the first term, right? This would be like my A sub 1. This is my A sub 2. Here's my A sub 3. Here's my A sub 4. First term, second term, third term, fourth term. Well, I want to figure out where is, oops, sorry guys. What is the pattern that I'm doing here? How do I get from 4 to negative 1 to negative 6 to negative 11? Hopefully you guys can see we're just subtracting 5 each time, right? Subtract 5, subtract 5, subtract 5, right? So we can already answer part C, actually. Describe the type of sequence. Well, if we're adding or subtracting the same number, that's going to be an arithmetic sequence. All right, I'll put C right here. State the next 3 terms in the sequence, part B. Well, if I keep going here, I know my A sub 1 was positive 4, A sub 2 was negative 1, A sub 3 was negative 6, A sub 4 was negative 5. A sub 5 then is going to be negative 16. A sub 6 is going to be negative 21. And A sub 7 is going to be negative 26. Okay. Box that in. So this was part B. Okay. Part C was the arithmetic sequence. Part D, what type of function would this be? Well, hopefully we know, since it's arithmetic sequence, it also has a constant rate of change of negative 5. This would be a linear function. And part A, we haven't actually really done part A yet. We know we have a common difference of negative 5. Right, we could put that down. Common difference of negative 5. But let's do one extra. Let's actually write down what this function would look like. Typically, if we have a linear function, right, it would look something like y equals mx plus b. And the good news about arithmetic sequences and geometric sequences is that it really follows along with how a linear function looks. It looks very similar. Okay? So if we were to plug in for our slope, m, hopefully we would know that it's negative 5. It would be y equals negative 5x plus b. This is where we don't know what b is. We know that b is the y-intercept. We know that is the y-intercept. In other words, when x equals 0. And that's very key. It's when x is 0. So if I wanted to write subscript notation of this sequence, I need to know one thing. Well, 2 things really. I need to know what's the common difference, which I got, which I can highlight with this. But I also need to know what is my b? What is my y-intercept so that I can fill in my subscript notation? So if I went to write this, it would look something like, let's write it as linear function first. It would look like y equals negative 5x plus, I don't know, right? And there's a very easy way to figure out what this is. It's a trick that we're going to learn in class. I think we will learn it actually in class today. So you should know this trick by now, because I'm making this on Monday night. But we want to figure out what is the 0th term. In other words, what would be a sub 0? Right here, what came before 5? Well, if I follow the same trick here, right? We're subtracting 5 from every previous term. Well, then what would go here? Blank minus 5 would give me 4. Well, if you think about it, it would be 9. And that would be my a sub 0. In other words, this is like saying this is my y-intercept here. Okay? This is my y-intercept in a sense. So my function would look like y equals negative 5x plus 9. But I want to actually write it as subscript notation, which would look like a sub n. This is the way we should always write subscript notation. A sub n equals negative 5n plus 9. Okay. And again, the way we got that 9 was by finding what is a sub 0. What is the 0th term? We found it to be 9, and that's where this came from. The negative 5n, that's my common difference. Okay. So, that was an arithmetic sequence. Let's do number 2 next, and then that will be the end of the video. Let's get this right here. Okay. Number 2, we have this sequence 3 to negative 1 to 1/3 to negative 1/9. Well, I don't know about you, but I see a pattern. What is that pattern? I see that we're starting at 3, going to negative 1. Looks like we're multiplying by negative 1/3. And then from negative 1 to 1/3, we're also multiplying again by negative 1/3. And then again from 1/3 to negative 1/9, negative 1/3. So that's typically the first thing I always look for when I'm doing sequences. I like to figure out what is the pattern, because then I know whether it's arithmetic or whether it's geometric. And again, 3, that's my a sub 1. Negative 1 is my a sub 2. 1/3 is my a sub 3. And negative 1/9 is my a sub 4. So right off the bat, part B, what's going to be the next 3 terms? Well, if I want to do a sub 5, I got to multiply negative 1/9 times negative 1/3, and that's going to be 1 over 27. A sub 6, multiply 1 over 27 times negative 1/3. That's going to give me negative 1 over 81. Then a sub 7, negative 1 over 81 times negative 1/3 would give me 1 over 243. Okay, so that's part B. Part C, what kind of sequence is this? Hopefully we see it's geometric. And then part D, what kind of function would this model? Remember, arithmetic models linear, geometric models exponential. Right? And then part A, we need some kind of subscript notation, some kind of formula like we did over here to model this sequence. Okay? And let's recall, what does an exponential function look like? Well, it looks like y equals a times b to the x, right? Where a is your initial, your start, and then b is your rate or your common ratio. In this case, our common ratio is negative 1/3. So we're already halfway there. Okay, so again, geometric sequences are also going to follow exponential functions, just like arithmetic sequences look like linear functions. So I'm going to switch colors quick because it's going to get just a little bit, just one change to what a geometric sequence looks like. My initial value for geometric sequences, what's nice is that I don't need to find a sub 0 because I'm not asking when is it 0. I'm saying what are we starting at? What's my initial start? And it tells us our initial start is 3. So already off the bat, we know our initial start is 3. So let me get this down. A sub n is equal to 3 times, what's my common ratio? It's negative 1/3 to the n power. Here's the one difference in geometric sequences. The one difference, it's not just n, it's n minus 1. That's the only difference in geometric sequences, okay? And that's very important to understand. We gotta remember the n minus 1. So if it looked like an exponential function, it would look like y equals 3 times negative 1/3 to the x. But since we're working with sequences now, it's a sub n is 3 times negative 1/3 to the n minus 1. That minus 1 is super critical, and we will understand why once we actually learn the formulas. But for now, that is what the subscript notation would look like. Okay. And here is just some steps on how to actually find or write a function for sequences. Identify the type of function. If it's linear, again, that's going to represent arithmetic. If it's linear, you're going to have an arithmetic sequence. And if it's exponential, you're going to have a geometric sequence. That would be your step 1. Step 2, write a basic equation, which we did up here. Here's my basic equation. My other basic equation I actually erased. And then you want to find the first term for geometric, and then you want to find actually the 0th term for arithmetic. And then you want to create a basic sequence. And this whole box here might seem a little confusing. It's just a little step-by-step. Once we get down the steps on how to actually do it, and we do more practice, this will become very easy. So if you're a little bit confused at first, do not worry. We'll get a lot of practice with this, and this will be the end of